Let's rock and or roll and get these questions out. Okay, 3 of the 6 homework questions. Fairly quickly, we're going to have some group work on that. It's not going to be group work, it's going to be fun non-group work, where I break you up into certain groups. All right. And yes, Michael Jordan wanted me to wear his shoes. He calls them RJOs. A little risky, but hey, he's my friend. You know, me and Michael Jordan are identical. We're the exact same person. I got cut in high school, and he got cut in high school. Can you imagine? He got cut in high school basketball. Michael Jordan. Morning. How you good afternoon? Julia, don't be late anymore, okay, please?
Yes, sir.
I'm going to need to mark the date today and every other day. Let's rock and roll with that. What am I doing? That. We learned sine 25. We just punch in sine 25 on a calculator. Bob, bob, boo. And we round to 3 decimal places. So the decimal 422 or 423. Everybody? 3, good job. Because there's a 6 here. It's actually on your calculator. It's 4226, blah, blah, blah. So you look at that number to see if it stays as those 3 decimals or it goes 1 up. This one, we learned inverse sine a lot yesterday. So when you have sine x or sine j or sine p, you do inverse sine to get j by itself. What a great number, or letter. And you do inverse sine. Everyone say inverse sine. Everyone say inverse sine. Everyone say inverse sine. That's how you say it. You don't say sine to the -1. It's inverse sine. And then you just punch that into your calculator. You know you press second sine. That's your inverse sine button. Second sine, decimal 712. Hut, hut, hut. Is that 45 or 46? 45. Okay, it's an angle. You might not know that. I don't care. You'll learn that. But anytime you do inverse sine, you're finding an angle. And that's important because every time you find an angle, you do inverse sine. And if you're finding a side, you don't do inverse sine. You cross multiply, which is what we're doing today. This one, inverse sine of 1/8. Everyone say inverse sine. Okay, and then let's talk math professional. Someone give that to me. I don't need to do it. Battery dead. All right. 7 degrees. Check. Sounds made up, but I think that's right. Okay, so let's do some group work. Again, it's not really group work, but you guys are Star Wars. So think if you want to be Princess Leia, Darth Vader, Darth Vader. You guys are Harry Potter. You're either Severus. What's a big snake's name? I think he's a big snake. Does the snake have a name? Oh, he does have a name. Good call. Or you can be Dumbledore. You guys are the Avengers. You can be Batman, you can be Thanos, you can be Iron Man, you can be Captain Canada. You gotta choose here. Really, you want to be Star Wars, Avengers, or Harry Potter? And Avengers, you guys are Avengers. Avengers assemble. What does all that mean? Not much. Just do this. If you're Star Wars, do this one. To 3 decimal places. If you're Harry Potter, do this one. And if you are Avengers, do this one, please. It's real quick. And when you're done yours, just look at the other ones, make sure you know how to do them, because you're going to be seeing them tomorrow on a daily quiz and on a real quiz. Actually, we'll probably just have a real quiz, because we are losing time today. We're going to get our textbooks at 1:15. All right, while you do that, I'm going to take attendance. So page 5, we got some sorry notes and exclamation marks and exclamation marks, and we got some underlining. So pretty important stuff right there. Now the first thing is, when we find an angle, we use inverse sine, inverse cos, inverse tan. That's the only time you do that. You find it in an angle. Remember we talked yesterday, the first thing we talked about is we're finding an angle or a side. If we're finding an angle, we use sine x and do inverse sine. If we're finding a side, we cross multiply, which we're doing today for the first time. Okay, so it's important to look to see what x is, a side or an angle, and that tells you whether to do inverse sine if it's an angle, or cross multiply if it's a side. No guessing. So let's talk about cross multiplying, and you just have to know how it works. Okay, it's a proportion, means two equal fractions, and the property is top times the bottom equals the bottom times top. You multiply these together, you get these together if they're equal. Okay, you could also, so kind of a shortcut, you could also multiply by the LCD and you get the exact same thing, but this is helpful especially for trig when you know this shortcut, when you go top times bottom equals bottom times top. Okay, so the first step of this, you would multiply 7 times 3 together, top of the left-hand side times the bottom, so go ahead and write that down, and then you would put that equal to this times this. 14 times x, or x times 14 is 14x. And I just want to do the first step. Okay, that's all we're doing the first step. This one, if I wanted to solve it, I would have put a 4 here, not a 3. Okay, because it ends up being a fraction answer. But we're not going to worry about the answer. We're just going to worry about the process of cross multiplying, so you know how to set up these trig equations, because you're going to be cross multiplying every time you find a side, unless it's a Pythagorean theorem question, which we're going to do after sine cos tan. Okay? So, first of all, you need two fractions. If we look at example 1, you don't have two fractions. You have one fraction. If you have the number 30, how do you write that as a fraction? Anybody? No? Good. So if you don't have a fraction, you just put it over 1. Okay, 6 is 6 over 1. X is x over 1. Sine 23 is sine 23 over 1. So that's the first thing you do, is make a denominator. If it doesn't have one, just put it over 1. Now you cross multiply top times the bottom. So you're going to do 4, and this is how I do it. I like to circle them. So 4 times sine 23, and what's 4 times sine 23? You just write it beside each other. 4 sine 23 means 4 times sine 23. And this one is 1 times x, which is just x. Okay, 1x is x, 1 cracker is cracker. That's how it works. And now we're not even learning this, but we're learning it before we learn it. So don't worry about it. I'll be teaching this. You don't have to understand this now. But now from here, we don't do much because x is by itself. That's what we want. We want to get x by itself, just like you did one in grade 7, 8, 9. So you just punch this in your calculator. Everyone punch in 4 sine 23 in your calculator. There it is. So 4 sine Monahan equals 1.5 or 1.6? 1.6. That's going to be our one-stepper. When we cross multiply and we're done. We're also going to have two-steppers when we're cross multiply and we have one more step to do. That's what this one is. Okay, so let's move on to Bobby, and we're going to create a denominator again. Put it over 1, as tan 17 doesn't have a denominator. And then we're going to cross multiply, top times bottom, or the numerator of the left side times the denominator of the right side, equals x tan 17. That's what x tan 17 means, x times tan 17. Now you usually put the x and the number in front of the sine, cos, and tan, okay? Now obviously, you don't need to know what we're doing after, because we haven't even talked about tan yet, or cos. But I just want the process of cross multiplying, okay? Top times bottom equals 6 times 1, which is 6. Now this one is a two-stepper because once we cross multiply, x isn't by itself. So we have to do one more thing. And if you can do this, you can do that red one as well. You divide by 5, divide by 5. Anytime you have something multiplied by x, or something with x that's being multiplied, you divide by that to get x by itself. So that's what we do here. This is x times tan 17. So the opposite of multiplying by tan 17 is dividing by tan 17, and that cancels. And it doesn't cancel because it equals 0, it cancels because it equals 1. Anything divided by itself equals 1. 1, tan 17 divided by tan 17 equals 1. 1 times x is x. So that's why it cancels. Now, little trickier, you put in 6 divided by tan 17. Not much trickier. Punch that in your calculator, 6 divided by tan 17. And then round its nearest tenth. I'll let you do it before I do it. I'll give you 5, 4, 3, 2, 1 seconds. The 19.6 or 19.7? 19.6. Okay, so just the process of cross multiplying. Go ahead and do C, please. Good job, copying it down. Thank you, thank you. Good work. Thanks for doing your job. What are you doing? Why are you cross multiplying that one? You don't cross multiply this one. You only cross multiply when you don't have sine x, cos x, or tan x. You write that down. Do not cross multiply. Okay, that's what you need to distinguish between when you cross multiply and when you don't cross multiply. If you understand that, trig is going to be very good to you. This one is like the sine x we had all day yesterday. Sine x, sine x, sine x, inverse sine, inverse sine, inverse sine. So this one, when you have cos x, to get x by itself, you do the opposite of cos, which is inverse cos. If you ever have sine x, cos x, tan x, you do not cross multiply. This one, you don't have sine x. You have sine 23. You have tan 17. Okay, so go ahead and punch that in your calculator. Even though we haven't done any cos, I'm sure you can do inverse cos 4 divided by 5 for me. And what'd you get? 36. So that's an angle, nearest whole number, and we get 36? Or 37? Okay, I must have misheard your decimal. 37? So 36 decimal 5, 6, 7, or 8, or 9? Oh, you got 8. Okay, I thought you said 3. Yep, so 37. Close, that number's closer to 37 than 36. Okay, now decide whether to cross multiply or inverse tan that one. Take your best guess. Try it. Alright, so remind me when it's 1:11. We gotta get to the library. Think of our textbooks. Okay, this one, you cross multiply or inverse tan? Inverse tan. Anytime it's tan x, inverse tan. Cos x, inverse cos. Sine x, inverse sine. Everything else is cross multiply. For a week anyway. So this is inverse tan. Okay, I'll trust that you do this when you calculate properly. So second tan, 6 divided by 5, what'd you get, somebody? Thank you. What'd you say, Brooke? So nearest whole number? 50. Check. Good. Yeah, there's a good. Couple thumbs over there. Good. Right on. Okay. So you learned how to cross multiply, and you kind of learned when not to cross multiply. Okay, so let's move on to actually doing questions where we cross multiply. AKA page 6. Fill in the blanks, read it, and once you've done that, just write down the formula right there that we're going to use to solve these triangles, or find x, I should say. All triangles. Alright, so calculate those with the calculator. There's 3 decimals. Calculator's not working. Okay, take out one battery. Put it back. Yep. Let me sanitize first. I don't know if this works or not. Try something. Alright, take all the batteries off and just, I don't know what else to say. Okay, you put sine 13 to 3 decimal places. Who wants it? Thank you. All said. You might get 0.225. Yep. Okay, this is the same thing because you'll see the relationship between sine and cos more in grade 11 and a little bit in grade 10. And tan 55 is one I want to talk about actually. So tan 55, you press tan 55, and you might be tempted to put 1.43, but that's wrong because that's not 3 decimals, that's 2 decimals. The 1 doesn't count as a decimal. It's only the numbers after the decimal. Okay, so if we look at this, it's either 1.428 or 1.429. And what is it? 428. There's Frosty. So why I put this section on is when you see sine 13 or tan 55, it's just a number. It's just a decimal number. You've been dividing and multiplying by numbers since grade 7. Okay, x over 9 equals 6 times 9. So you've been multiplying and dividing by numbers. These are just numbers we can multiply and divide by. So when you see sine 13, don't think it's a fancy smancy Harvard, Princeton number. It's just a decimal number. It's the ratio of when the angle is 13 degrees. It's the opposite side divided by the hypotenuse side. It gives you a fraction. When a sine goes, it's always under 1, between 1 and 0. So we can multiply and divide by them, even though we're more comfortable with 3x dividing by 3. Well, now we're going to be dividing by sine 13. It's the same. You're just dividing and multiplying by numbers. All right, let's rock and roll with example 1. So most of your questions on your tests and your quizzes will be with triangles. You have to set up, so we're going to start with the formula. You already wrote it down. Now you have to understand what to put after sine, because everything sounds good. Sine x sounds good, sine 33 sounds good, sine 24 sounds good. You cannot guess. If you put the wrong thing in, 0 immediately. It doesn't make any sense. So what we wrote down yesterday is that it has to be an angle. You can only take the sine of an angle. What's inside the triangle? Angles are inside the triangle. In this case, it has the degree symbol, but most of the time it doesn't. Okay? So is it sine x, sine 33, or sine 24, everyone? Sine 33. Once you get that right, remember what I told you, to draw an arrow from the angle across to the opposite side, everything else should fall into place. X is the opposite, so we put x on the top. Hypotenuse is the longest side, we put it in the denominator. And now we have a cross multiplication question. So with sine x, you would inverse sine it. Here we have to cross multiply. Right. I'll write that down, quick. Cross multiply, again, I like to circle it diagonally. Those are the two numbers that are being multiplied together. And 1 times x is just x. There's a 1 here, but you don't need to put it. Good job. Now remember what I said. Half the time we're done cross multiplying, we're done. Half the time we have to do one more step. So the question we ask is x by itself. If x is by itself, we're done. All we have to do is punch this into our calculator. So everyone punch that into your calculator. This is a one-stepper where we cross multiply and punchy. By the way, you guys can cancel your Netflix subscriptions. You'll be getting the math textbook for evening entertainment. It's good for supper time. Goes well at bedtime. Just read it all during commercials, during hockey games. All right, who's going to win the Super Bowl, gentlemen? Not Tom Brady? Not Tom Brady. Okay, what's 24 sine 33? Punch it in. 24. Check. There you go. 24 sine 33. And now you're going to round this because you're finding the side to the nearest tenth. Nearest one decimal. So the 13.0 or 13.1? Okay. So write down 13.1. You have lost some marks here because you haven't put the units. Okay, these sides are measured in centimeters. You must put centimeters. You don't want to do all this work and lose a half a mark. So write this down. Remember units. You don't have to put degrees and triangles for me. Oops, I just put remembers. Remember units. I know what I meant. Remember units. You don't forget to put centimeters, or you lose a half mark every time. And if you put 13, you're going to lose a half a mark. You have to round to nearest tenth when you're finding a side. So at the beginning and the end, what am I doing? If I'm finding a side, I cross multiply. If I'm finding an angle, x is inside, then I inverse sine and nearest whole number. If I cross multiply, find a side, I remember units. I put centimeters. If it doesn't have any units, it just has 6 and 7 for the sides, you don't need to put units. Well, you can put centimeters if you want to. If you put meters and centimeters, I'll ignore it once. If you do it twice, I'll probably take a quarter mark off. If you do it once, I don't care. At least you remember units. Unless it's a trickier unit conversion question. All right, try example 2, just like we did, please. Start with the formula, bless you. Sine equals opposite over opposite over hypotenuse. And I will pause while you're working on that. Let's forward first. Start with the formula. Sine equals OPP divided by hippopotamus. And somebody tell me what to write down. Is it sine 61, sine 55, or sine x? Someone doesn't say anything yet. Sine 61 is perfect. Why? Because it's the angle. You have to put the angle here, please, to get anywhere. Put sine 61, you're on your way. The arrow points to the opposite side, which is in the numerator. Hypotenuse is the longest side, the other side across from the right angle. From here, you have to know whether to do inverse sine or cross multiply. You only inverse sine when you have sine x. So you cross multiply, get 55 sine 61 equals 1 times x, which is just x. 55 times sine 61. Punch that in the calculator. I'm not going to. Someone did it. If you got them all right, just tell me what you got this time. Someone different. New voice. Come on. Thank you. You say 48 decimal 1? Is that what you said? Check. 48 decimal 1. Yep. Okay, good job. So that's the one stepper where we cross multiply and x is already by itself, so we don't have to divide by sine 61 here. You only divide by sine 61 when it's with x, when on the same side with x. Okay, let's go with this guy. Draw the arrow across from the angle. And here is the formula. I'm not going to write down because I'm running out of room. So sine of the angle, what's the angle, everyone? 41, good. Equals, is that 18? Who wrote that? Divided by x. And now, over 1, cross multiply, you get x. Sine 41 equals 18. 1 times 18. And now you're stuck. You hit a roadblock. You don't know what to do. Okay, there's only one thing to do here to get x by itself. You do the opposite. You divide by the number with x. So you divide both sides by sine 41. Everyone say sine, not sin. Say sine 41. Sine. Now that cancels. What's 18 divided by sine 41? Who's got all those answers? Who got them all right? Somebody besides Leyland. Thanks anyway, Leyland. Anybody? Thank you. 27.4 centimeters. Good job. Anybody get that? Up. Lots of thumbs. Bravo. So homework done. No, you actually won't have any other homework. You're welcome. Okay, so page 7. We're done sine. Now it's cosine. Cosine is exactly the same as sine. You do the exact same steps. When it says cos x, you do inverse cos. When you find a side, you cross multiply, either a one-stepper or a two-stepper, but instead of putting sine, you put cos. You're dealing with adjacents divided by hypotenuses. In fact, it's so similar, I don't have to even tell you how to do example 1, 2, and 3. You're going to do that yourself when we come back from the library. Okay, so notice how cosine is almost exactly like sine. Okay, so cos 30. Punch that in your calculator, 3 decimal places. Is it decimal 5? No, that's cos 60. cos 30, cos 30, hut, 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 is a decimal 866 or 867? Oh, let's press another 6. Example 2. Okay, so I haven't even taught you this yet. What do you think you do with cos p equals decimal 343? Inverse cos. Good. So just like you had sine x or sine p, here you have cos x or cos p, so you get p by itself by doing the opposite operation, or the inverse operation of cosine. That's inverse cos. Okay, and then punch that in your calculator. Second, here we go. Second cos, decimal 343. And this is an angle now. Again, anytime you do inverse sine, inverse cos, you're finding an angle. So angle is nearest whole number, which is 70. And would you put centimeters if it was a triangle? No, because there's an angle. So if you put centimeters, you would lose a half a mark. It's in degrees. Good, 70. Anyone over there? All right, let's go to the next page. Come on, gals. Hurry up and write that down. If you didn't do it, you got it. Okay, example 3, next page. If you haven't done it, do it. Just came in last couple minutes. If not, I'm trying to stall because you don't really need to move on to the one stepper, two steppers. All right, next page. Nope, nope. Yep. All right, cos half my nickname is equal to 1/6. So what's the opposite of cosine? Inverse cos. So half my nickname equals inverse cos of 1/6. What's half my nickname equal? 80? Why, Babineau's football number when I was wide receiver. Then in high school I played running back, defensive back, and then I went to wide receiver with the Huskies because they gave me a choice and I liked that better. And punt return. Okay, what's my nickname? Half my nickname's Q. The other half is Q. I call myself Cutie all the time. Sometimes for hours, just in the mirror. All right, I think we're done. That's one awesome day.